Right, you have the cortex of the kidney. Right, as you go deep to the cortex, you have your medulla, the renal medulla, and at the renal medulla is where you would see your renal pyramids. Now the renal pyramids are basically where these parts of the nephron and the collecting ducts will pass through. Right, and the pyramids end at the renal papillae. Right, so these are the renal papillae there. From the renal papillae, you go into collectively what's considered the renal pelvis. The renal pelvis initially starts at the minor calyces, right, where those renal papillae end. Right? So that urine is drained into the minor calyces. From the minor calyces, it goes to the major calyx, and then from all of these major calyces, it gets dumped into that renal pelvis. And then from the renal pelvis down to the ureter. From the ureters, if we go to this model, right, the ureters then make their way towards the posterior inferior aspect of the urinary bladder, which would have been here. And then from the bladder, the exit route would be the urethra. So that's what you would have seen there. As far as the nephron structure, in the nephron structure, you see the glomerular capsule here. Right, in this particular section, you remove the glomerular capsule and you see the glomerulus. And we know that the glomerulus then is where filtration is happening. Right? So at the glomerulus, you have your afferent and your efferent arterioles. The afferent is what's supplying, the efferent is what's draining. Because of the size difference as far as the radius, you end up having a lot of pressure here and then filtration. And so when that filtration occurs, everything gets dumped into the capsular space. And then here you can actually see the glomerular capsule and the cells that make up that capsule, right? Simple squamous epithelium. From there you proceed out to the proximal convoluted tubule, right, which you can see here on the model. So that's our proximal convoluted tubule. This is where reabsorption is going to occur, right? You can see the cuboidal cells here with the microvilli, right, to increase that surface area for absorption. You also should consider that around these tubules here you have your peritubular capillaries. And those capillaries then will reabsorb everything from these cells back into the blood. Right, so this is the reabsorption portion. From there you make your way down to the descending limb, to the nephron loop, and up the ascending limb, which if we were looking at the juxtamedullary nephron, these parts of the nephron would be involved in concentrating the urine. Right? Remember, this is the countercurrent multiplier. You would have the vasa recta here for the countercurrent exchanger. All involved in making and keeping that salinity gradient in the medulla. Then as you make your way back up, if we go back to this one, here's the distal convoluted tubule. Right, the distal convoluted tubule, you can still have reabsorption and secretion as well. Eventually this dumps into the collecting duct, which will transport that urine to the minor calyx. Now the only thing that we can do here is take out water. That would be under the influence of ADH.